Lesson 4, applications of vectors, the famous river question. An observer is standing on the shore of a river which flows to the east. Flows which way? Do you see a compass direction? North, east, south, west. Have I written something down? Do I feel better? Yes. Cheap trick, but it works. Okay. River flows to the east. He sees a boat traveling across the river. The boat is pointing due north, but the current gives it a resultant velocity of 8 meters per second at 65 degrees north of east. North of what? And I see an angle. I suspect components, but let's now tackle this. So do you see all the mental little checklists I brought to that already, Aiden? Which way is the river flowing? So I'm going to DULP. What does DULP stand for? And I guess if the river's flowing east, river's flowing that way. Rivers flow down the river. Every once in a while, when I tell a kid the river's flowing east, I'll see somebody draw the river like this, and they'll say, that's the current. Please understand how rivers work. They flow downstream, not across stream, so don't draw that. That's something I can't teach you or fix. That's just understand how water works. So you laugh, but it happens. And of course, then everything's wrong from then on in, right? Okay. You know what? I'm going to be clever. I'm going to call that V current, just so I'm labeling stuff. I don't know what it is yet, or do I? Well, what's A want me to find? Okay, all right. I haven't yet drawn everything, so river flows due east. Sees a boat traveling across the river. The boat is pointing due north. Don't draw this yet, just look up. So the boat is pointing that way. Which way would the water push it? Okay, so that's why even though it's pointing straight up, it's also getting pushed sideways. So its resultant velocity, Cleo, can you read me after the word of, starting with the 8? Can you read out to me that, please? North of what? North of what? North of what? I'm going to go east first. North of east. How many degrees north of east? 65. And you know what? I'm going to, oh, I put the 65 in the wrong place. The boat velocity is going to look like this. I'll use the shore as my bottom part of the triangle since I happen to draw it there. I drew the dotted line a bit higher, but that's okay. I'll just ignore that. That's the boat velocity. How big is the boat velocity magnitude? How many meters per second? That's going to go there. 55 degrees. Does that make sense? Yeah, the boat will be getting pushed sideways. I'm okay with that. Okay. Is there an angle? Did I say angle? Components. Is there an angle? Did I say angle? Is there an angle? Did I say angle? Okay, that's almost going to be a reflex. You can take that to the bank 99% of the time. I'm going to DULP, but I'm going to draw this triangle a little bit bigger, Karn. Over here I got room, so I'm going to draw it. There's the 8. There's my components. By the way, Wes, that was a great question about the homework you asked, because what a great segue into today's topic. What's the angle? 65 degrees. Color, 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 color. It looks like we're using velocities. So this will be Vy. This will be Vx. What is Vx actually if you look at my picture? No. It is. But what is it as a thing in my picture? Aiden, what? That's the current velocity. Look. That's how fast the boat is getting pushed sideways. That's got to be the current. Okay? So I labeled it X in my triangle, but I'm going to always think, haha, that's the current. By the way, what's Vy then? Like, I know it's opposite, but like, what is it in terms of this physical situation? I think, what? That's the boat motor. Boat motor plus current. I got to be fussy. Technically, the boat velocity is the slanty because that's how the boat is moving relative with the ground. But the boat motor is pushing up north, however fast that is. We can find that too. This is the famous river question. So let's do current first. What did you say? Adjacent, you said, yes? So adjacent, what's the 8? Which trig function? Yes, it is. Good. Of course it is. Cos 65 equals, and you can either write Vx, you know what? Here, I'm going to put a little x underneath current so I know they're interchangeable. You could write V current if you wanted to, Allie, but I'm lazy enough that Vx is only one letter and V current is 4. I'll use Vx and just do the translation in my brain. Yes, I'm that lazy, but organized. Over 8. How would you get the Vx by itself? You need to move that 8 over. How? So get your calculator out. Let's crunch that. I don't mind if you don't write 8, Vx equals 8 cos 65. If you can go from this line to your calculator and an answer, William, I'm fine with that. If you can't, if you want to write the extra line, go ahead. I'm fine with that too. But Josh, if you're wondering, I'm not going to be, as long as I see the trig function. If this was a written question, I would give you 1 mark if I saw cos, but I wouldn't give you any marks if I saw Vx equals 8 cos 65. I would say, just do it, solve it. So 8 cos 65. Do you all get 3.380? 3.38, 3 sig figs, and there's a 0 right after there. That's probably a pretty good place to round off. If they asked for a direction, what direction would you say? East. I'll write it just in case. They said how fast, and I don't know when by how fast, did they want just the speed or did they want the velocity? I don't know. So I'll cover my bets. B. How fast is the boat moving across the river? Which vector is that in my triangle? Vy. Vy. Yeah. Okay. Now, if the river was flowing north-south, all of this would flip on its end, but I can still handle it. Here the river is flowing east-west, east. Okay. Opposite. Which trig function? Sine, you say. Hey, I think I can just backspace and edit. Ha. Sine. And I get 7.25. Oh, nice 0 there too. 7.25. Good place to round off. Meters per second, and if they had asked for a direction, I would say north. If you wanted to do a double check to make sure you hadn't done a mistake, you could go 3.38 squared plus 7.25 squared equals, and when you square root, that should be really close to 8. It might not be exactly because we rounded off, but it does give me my hypotenuse. I could do Pythagoras to see if I get what I started with. C. McKenna, can you read C to me, please? Stop. Gulp. That'd be this way, yes? That's a distance. That distance, is it an x distance or a y distance? It's a y distance. The key mistake that kids make, and the one I'm going to try and beat out of you this year, direction matters. You cannot put an x value into a y equation, and you can't put a y value into an x equation. Your directions have to match. So keep reading after the comma. Time. Okay. We're just starting out. For the river question and the airplane crosswind question, can you see this is, I could also have made this an airplane crosswind instead of a river current. It's the same physics. For both of them, you can assume A is 0. We did one at the end of last lesson where A wasn't 0. We did VF equals VI plus AT. We did a vector acceleration. I'm not going to do a vector acceleration question with you as a airplane river question. I could, it's just overkill right now. So remember D equals VIT plus a half AT squared? But A is 0, so can you all write D equals VT plus a half 0 T squared, which is plus a half 0, which is plus 0, which, why would I write that? Except, here's the modification this year. We're in a two-dimensional world. The distance they gave me is a vertical distance. That's that 256. In fact, if you want to, up here, you could put a little dy equals. So what's going to go on the velocity? A y. If I'm going to use a vertical distance to find the time, I better use a vertical velocity to find the time. How would I get the t by itself? McKenna, how would I get the t by itself? So glad you all bought into formula manipulation last year, because you can just derive this so much nicer. So you're telling me t is going to be the vertical distance divided by the vertical velocity. What's the vertical distance, McKenna? Yep. What's the vertical velocity? And here's the important thing, not 8. One of the things you're going to hear me say is once we turn the slanty velocity into its components, we're never going to use the slanty, yucky velocity again. Okay? So what is, 7.25. Yes. Yeah. Not in the same direction as the distance. I can't do physics with that and that in the same equation. Which is, I would measure straight across in a vertical direction, in a north-south direction. Yes? No, it's not. I'm not traveling 256 meters this way. I could calculate it if you really want me to. It would be some slanty distance that I'm traveling this way that I don't know. Right? I'm traveling, if I'm using this velocity, I would need to use a distance that was also at a 65-degree angle. I could crunch that, I guess, but why? It's extra work. It is the original speed, but the original speed in the direction of the distance that I'm using. The original speed in the direction of the distance that I'm using is 7.25. You're asking good questions, but what you really need to realize is, I can't just plug in numbers. I have to match directions first. I have to do physics with the same directional components. And I'll convince you some more, and I'll especially convince you a couple lessons from now. But meanwhile, what's the answer? How many seconds will it take you to get across? You get 35.310, 35.3? Okay. Now, that's the boat moving straight across. At the same time, Carter, it is getting pushed sideways, so it's not going to end up straight across the river. It's not going to end up right here. It's going to drift. It's going to end up down here somewhere. How far? I think that's the next question, isn't it? Yeah. How far down the bank will the boat have moved? So let's go back to our DULP up here. If it went straight across, it would end up there. I think this wants me to find that distance. That distance, horizontal or vertical. I'll call it dx. Okay. A is still 0. It's still going to be d equals vt, except you told me that that distance is dx. Which velocity must I use now? Vx. Why can I use time in both equations? It's a scalar and has no direction. So time I can use wherever. The time to go across, it will drift downstream for exactly the same amount of time. What was Vx? I've scrolled to the next page, but you have it on yours. Sorry? 3.38. And what was time? Oh, I have this. I'm going to use my answer button instead of 35.3 because it's less work. But I will go 3.38 times answer button. If you really, really want it to be hyper accurate, you could go 8 cos, whatever the angle was, times answer button, but good enough. It's going to end up about 119 meters downstream. Is that all right? If you wanted to add a direction, east. What would the direction be for part C, by the way? What did we find? It's a scalar, no direction. Sucked you in. No direction. It's a scalar. Starting to see better this year the difference between scalars and vectors. Because last year we were kind of casual with it because I wasn't doing two-dimensional stuff. Okay. E. What's the boat's engine velocity? William, what's the boat's engine velocity? Too slow. Connor, what's the boat's engine velocity? Too slow. Allie, what's the boat's engine velocity? When I do that little dumb dance, what I'm really saying is, you know it already. You just need to figure out how you know it already. What is the boat's engine velocity, folks? That's that Vy, right? Just reinforcing that okay, Veng is Vy. What was it, 7.25 or 3.5? 2.5, thank you. Sorry for making fun of you, but it was a good way to reinforce, right? So now we can put everything together, because of course, what if you don't want to end up 119 meters downstream and have to walk all the way back? What if you actually want to end up right across from where you left? You'll have to point the boat into the current. You'll have to point the boat kind of that way. And it's going to look a little bit strange because the boat is going to be pointing that way but moving straight. But if you watch on the Fraser, you'll see this all the time. So it will. Here's the question. At what angle would I need to point it to go straight across? Got the argument? So that's what F is using. We're going to assume that we keep the revs exactly the same, so we're still going to be traveling at 7.25 meters per second with our boat motor. Okay. What direction should you point the boat in order to travel in a straight line due north? What will the resultant vertical velocity be? I think we better redulp. Question, Wes? Deep thought? Okay. So here's my argument. Here's the river. We're going to point the boat, I don't know, that way. It might be steeper It might be shallower, but there's something like that. Because then it's going to get pushed, Connor, downstream. And when I add those together, should end up going straight across. Got the argument? Oh, and you know what? I know how fast this arrow is. This is which way I'm pointing the boat now, which means this is going to be which way the boat motor is pointing, which means this is going to be 7.25 meters per second. What else do I know? The current. How big is the current? And this is Vng equals 7.25 meters per second. The combination of those two, I would like to push me straight across. I'm going to say that again. The combination of those two, is that a hand-up question? Yeah. That's a good thought. He's saying, wouldn't it be 65 degrees? Let's find out. The combination of those two, I would like to push me straight across. The combination of those two, I would like me to push straight across. To push me straight across. I'm going to phrase it a tiny bit differently. The addition of those two, I would like to end up pointing straight across. Did I say addition? How do I add two vectors? Yeah. Now this is a different diagram than you're used to. Watch. It's going to be, there's the first vector. And then put your pencil down and look up. I'm going to add to it the current. Don't draw it yet. But here's the beauty. I know what the resultant is supposed to look like. Do what? So I know don't draw the current that big because that resultant is not due north. I also know don't draw the current that short because that resultant is not due north. I'm going to start to draw the current. You all tell me when to stop. And you can see the scale kind of takes care of itself. And this I'll call VR for V resultant. Draw that. Now Connor had a good hypothesis. He said, wouldn't it just be 65 in the opposite direction? First of all, have I convinced you that that must be the dimensions of the triangle because it's the motor plus the current still? Is that okay? Let's do the trig and see if you're right. Spoiler alert. No. Okay. So A said, what direction should you point the boat? I think I'm going to find that theta right there because we always do directions based on where the vector is coming from. .38, opposite, adjacent, or hypotenuse. What about 7.25? How will I find the angle? Up until now, every question where you found an angle was tangent. And that's why I said to you, it'll usually be tangent for a more simple, straightforward question. But here, which trig function will I use to find theta? Sine. Okay. So A, I'll go sine theta equals 3.38 over 7.25. How do I find the angle? Second function sine or shift sine. Technically it's called inverse sine or arc sine, but whatever. I don't think you get 65 degrees. Do you? No. What do you get? $27.8? Yep. What of what? North of south, east of west, what of what? West. West of, do the nice line. The nice line is the of, so of north, west of north. Or 90 minus that, 62.2 degrees north of west. That would be if you found the angle with the shore. I'd take that. That would be if you had drawn the current first and then drawn the motor and added them tip to tail that way. Because if you did that, you would have that. I always take both. Is that okay, Connor? Have I convinced you? Yeah. But by the way, you're not the first kid to think that, okay? Oh, B. What will the resultant vertical velocity be? The nice thing is I can already tell you the direction. North. Due north. How can I figure out how big that is? I would use Pythagoras. I could use SOHCAHTOA trig, but if I got this angle wrong, I'm getting this wrong. Of course, now, though, in Physics 11, we tried avoiding using an answer to find another answer. Physics 12, you're always going to be using an answer to find an answer to find an answer. So suck it up and you can do this. But Pythagoras, am I finding the hypotenuse this time? So it's not going to be this squared plus this squared. It would be 3.38 squared plus VR squared equals 7.25 squared. There's your Pythagoras equation. How would I get the VR by itself? Subtract what? Stop using terms like it. Tell me what we're subtracting or adding. Subtract the 3.38 squared. Okay, so it's going to be 7.25 squared minus 3.38 squared equals what? Oh, square root. Don't forget that. If this was multiple choice, would I have 41.1 as one of the answers to pick from? Yeah. 6.41. How long would that take to get across? Well, the nice thing is, McKenna, this 6.41 is a VY. It's in the vertical direction. So I could just go 256 meters divided by answer button. It'll take a little longer. What was the other one? 35.3 seconds, I think? 39.9. But we're not having to walk 120 meters to get back to where we wanted to go. Okay. Handy hint, key idea. If they give you a vertical distance, a dy, use Vy to find t. If they give you a horizontal distance, use Vx to find t. Don't put a horizontal into a vertical. Don't put a vertical into a horizontal equation. You cannot do that. And we're almost never going to use the slanty because it's neither. Let's do another one. This is a clone of the question we just did. I don't like that, so I'm going to change two things. Are you ready? How about an observer is standing on the shore of a river that flows to the, cross out the word east. Let's make it north. That's step one. And then the boat's velocity on the river, instead of north of east, let's make it east of north. And the boat is pointing due east. I should have done this years ago. I just thought of this right now. You're the first group I've tried this with. Let's see if I've made up a good question. Do you see directions, Karn? So, compass rose. Especially since I think all of you have turned the page, right? Okay. Karin, which way is the river flowing in my new modified question? North. So if I dulp, river is going to look like this, with the current going that way. There is the current, which is also going to be Vy. Could also be flowing south. I'd call it Vy. I don't think I'd call it negative. I would just let south be positive because that would make the math way easier. Sees a boat traveling across the river. The boat's velocity is 12 meters per second at 55 degrees. What? East of what? East of what? So we would start out going north. East of north. Yoink. How many degrees? Okay, so it's going to look something like this. 55 degrees, and there's a 12 there. I'll even put units on there because it's too easy to get confused about stuff in this diagram. Okay. What does A want me to find? I think that's going to be Vy. And is there an angle? Did I say angle? Everybody? Components. I could try solving this triangle here, but I've learned the hard way. It's nicer to keep my river a little uncluttered and take 1 second to redraw the triangle. And I have a bunch of white space right here. So I'm going to go yoink. There's the 12. And I guess my components are going to go d. This is going to be Vy, also V current. This is going to be Vx, which I think is also V motor, because it does say the boat is pointing due east. Lovely right angle there, and this angle here is 55 degrees. Is that okay? Good. Try A and B on your own. Color, 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 color. Aiden, do you remember me sometimes last year in Physics 11 saying the phrase built-in error check? Okay, there's a built-in error check here, sort of. What's the angle this time? How many degrees? If it was 45 degrees in a 45-degree triangle, that's an isosceles triangle, your Vx and your Vy will be identical. Okay? Is 55 kind of close to 45-ish? I was expecting my velocities to be close-ish. In other words, if I got 1 meter per second and 12 meters per second, I'd panic a little. Now, if it's a really small angle or a really big angle, like 12 degrees or 74 degrees, then they will be far apart. So there's a bit of a built-in error check, but that's very rough, very rough. But since I have that trick in my back pocket, I'll always pass it on to you as well. You can use it or not, but sometimes it's helpful to look for typos on your calculator is really what I use those tricks for. So when I saw those two answers, I thought I probably did it right. Okay. If the river is 320 meters wide, that's going to be this way. That's a distance, a dx or a dy? Dx. How long does it take to cross the river? A is still 0. If you're bored sometime, come by either during a Y block or during a blended when no one is here. I can show you if there's also an acceleration. The questions get longer more than anything. I can't even say they get much tougher. It's just, instead of d equals VIT plus, it's going to be d equals VIT plus a half AT squared. And it's a quadratic and it's a bit of a pain. It's doable, but So A is still 0. How long does it take to cross the river? McKenna, we're going to use your equation again, d equals VT. But this time it's a dx, so I'm going to use a Vx. Question? This is good. Josh or
the boat is traveling left, right? Yeah.
The boat is actually getting pushed upwards. It's traveling right and up. Yeah. Current is Vy. Oh, did I write? Candy for Carter. Dewick made a dumb mistake because he was repeating the last question. Wow, I'm sorry, folks. That's terrible of me. And those of you on YouTube, I probably just shattered your... Oh, man. That was so dumb. So, mask up. Carter gets a... For those of you who are watching at YouTube and you're screaming at your screen, you were right to scream at the screen. I screwed up X and Y. You know what? That's the other one I will mix up. And now you're knowing why I always draw compass rose, because I botch that so often. And I got to concentrate on my X's and Y's. Okay. So, continuing on then, I think we're going to say time is dx over Vx. It was 320 divided by 9.83. And I get 32.553. I'll call it 32.6, but I'll see if I can't leave this on my calculator for further calculations. And that's time, seconds. Direction, scalar. And again, if they'd asked for directions for these ones, current is north. Now that I got that right, thank you, Carter. And boat motor would be east, or left to right. How far down? Cross out the word down. Up. Because I changed the question. Now we're moving upwards. Okay, so now I think they're asking me to find that. That thing. That's a distance. Oh, a d what? dy. Okay. So I think I'm going to go like this. D equals VT. A is still 0. Oh, by the way, it was always D equals VIT, but if A is 0, is your initial velocity changing at all? So V initial is V final, is V average, is whatever, just V. Kind of nice. So it's going to be dy equals VYT. So Vy, which we finally got right, thank you, Carter, was 6.88 times my answer button. All right, 32.6, but okay. $224 if I go to 3 sig figs. I slumping? Who got that one first, Carter or Mark? Mark? Okay, candy for you, Mark, later on. What's the boat's engine velocity? I already know. (9.83) is the engine velocity. Because that's which way the propeller is pushing it. 6.88 is the current. 12 is the vector sum of those two, but that's only for that specific angle going with the current. And that is really a better answer to your question, is when you said, is it the same? No, because it's not going to be the same two vector sums, and you're not going with the current and in the same direction. Okay? It's not symmetrical. It might be, if it was 45 degree angle, if it was a 45 degree angle here, I'd have to run the numbers. No, it still wouldn't. You're right. Okay. So, sorry, 9.83? All right, we want the boat to land directly across from its starting point. So here's our DULP. The current is flowing this way, which is also Vy. So which way would I have to point the boat to get it to go straight across? Into the current or with the current? This is going to be, I wrote V current up here. Wow, am I slumping? V engine up here. At least I caught that one. Wow, Duick. This is going to be V engine. I'd like to combine these two. What's a fancy math word for combine? Add. Tip to tail, you say. So for part A, my triangle is going to look like this. Oh, look up. I could go current plus engine, or I could go engine plus current. When you're creating a brand new vector triangle, when you're adding two vectors together and they're not all at nice right angles, always do the ugliest one first. Draw that one first. Trust me, it'll be easier to get the triangle. Which vector looks uglier, the engine or the current? The engine, because it's slanty, yes? So if you draw that, which was 9.83, because I know what the resultant is supposed to look like, tell me when to stop drawing the current. What was the current as magnitude? 6 point, what? That will give me straight across as a resultant. The direction would be where the vector is coming from, right there, not where the vector is pointing to. Uh, 6.88, opposite, adjacent, or hypotenuse. Opposite? 9.83. Ooh, not tan this time. This is a tougher question. Which trig function to find theta? Sine theta is going to be 6.88 over 9.83. (44.4), almost a 45-degree angle, but not quite. Theta equals 44.4 degrees north of south, east of west. What of what? South of east? Yeah. And then B asks the magnitude of the resultant. Going to use Pythagoras, but since it's not the hypotenuse, I'm not going to go a squared plus b squared equals c squared. I'm going to go c squared minus b squared equals a squared. Yeah? So it's going to be 9.83 squared minus 6.88 squared. That equals the resultant squared. That looks like a 5. Can't even read my own writing. 9.83 squared minus 6.88 squared equals square root. It's going to be just a bit bigger than 7 because square root of 49 is exactly 7. 7.02. Meters per second. How long would it now take to get across? Well, what was the distance across the river? 300 and something? Or am I remembering wrong? Sorry? 320? Okay. So, and this is also a Vx. So 320 divided by that, it would take 45.6 seconds. What was the original time? Sorry? 32.6. So an extra 13 seconds on the boat, but you save yourself a couple hundred. Am I wrong? People looking at it fun. Yeah, 32.6. So it would save you some time. It would save you some walking, but you'd be on the boat longer. Okay. This is also done by airplanes, jet planes in crosswinds. Because if you're a jet plane, you don't let the wind push you where it wants. You know where you want to go. We need to land in that city over there. So which way do we point our plane into the wind so that the combination of our jet engines and the wind point us in the direction that we want to go? Is that all right? So you're probably gonna you could solve these. Here's some of your homework. You're gonna need to do the diagrams on a separate piece of paper. One is good. You can skip 2. By the way, 2 is easy. It's west plus east. Oh, here, would you need to actually draw tip to tail if it's west and east? Winner minus those are bigger minus smaller. So that's why I'm skipping 2. 1 is the same, but just to jog your memory. Ooh, 3 is going to have vectors. I'll skip 4. 5 is going to have vectors. 6 is good. 7 is good. I'll skip 8. 9 is good. Here's our river question, number 10. Here's another river question, number 11. I'll skip 12. I'll skip 13. 14, you're going to add 3 vectors. Take a look at number 14. Which 2 vectors would you add together first? Yeah, and then turn it into 2 vectors. So one of the strategies we're going to use all year, Cleo, is, oh, you give me a tougher question, I'll turn it into the question I already know how to do. Oh, you give me 3 vectors, I'll turn it into 2 vectors, and then it's tip to tail. Okay. 15, here's a conceptual question for you to think about. I like number 16, I like number 16, I like number 16. What does it want you to find in number 16? What's change in anything? Did you say minus? How do I subtract vectors? I'll let you think about that. Okay? But that's going to be one of the main areas where we use subtraction of vectors. 17 we just did as well. You also got a take-home quiz. I'm going to press pause for a while. Now, here's the nice thing. The next lesson is a review of VF equals VI plus AT, VF squared equals VI squared plus 2, those ones. So that'll be in one day what we spent 3 weeks of physics, or probably a month and a half of physics 11 doing. But I'll probably get to that today yet, but I'll probably finish it off tomorrow because I know I've thrown a whole bunch of stuff at you right now.